So today we're going to be looking at a piece of hardware that solves a very specific and I think a very common infrastructure headache. It's the Thor Broadcast H IPRF-4QAM.
It is quite a mouthful of a name,
hmm
but if you sort of break down the acronyms, it tells you exactly what it does. IP to RF 4QAM, it's basically a bridge.
Right, a bridge. Because the reality is we live in a technologically messy world. You have all these modern video sources streams coming over Ethernet, IP cameras, digital signs.
Mhm.
But then you have entire buildings still full of legacy coaxial cable. So the mission for this deep dive is to figure out how this little box translates between those two languages without, breaking the bank.
Exactly. The technical term for it is an edge QAM modulator.
hmm
And in simple terms, it just sits at the edge of your network.
Okay.
It takes the video data that a computer understands, we're talking UDP or RTP streams, over an Ethernet cable, and it modulates it into a radio frequency signal that a standard television understands.
So you're essentially tricking the TV. You're making it think it's receiving a normal broadcast cable channel when what it's really getting is a data stream from a local server.
The perfect way to put it, yeah.
Yeah.
And if you look at the specs here, the density is what really stands out to me. You have one dedicated data port, right?
Yeah, one port,
And it can ingest up to 63 different IP addresses.
which is pretty wild for a box that's only, what, 7 inches wide? You could just stick this on a desk or mount it on a wall, and it replaces what used to be like a whole rack of equipment.
Absolutely.
And for under $2,500, I saw it was down from nearly $3,000. That is a huge shift in the barrier to entry for setting up your own local TV system.
It is. It's definitely designed as a low-cost solution for places like hotels, hospitals, or corporate campuses that need to distribute their own content. But the real value here isn't just the size or the price.
It's the efficiency.
That's the efficiency.
Mm.
The documentation really highlights multiplexing, which is where the fun math comes in.
This was the aha moment for me reading through this. Because in the old analog days, one channel took up one frequency. Channel 3 was channel 3, and that was it.
That's right.
But this device uses QAM quadrature amplitude modulation, which lets us, well, stack the content.
Right. Think of the frequency as a pipe. In this setup, let's say a QAM 256 configuration, you have roughly 38 megabits per second of bandwidth available in that pipe.
And if your video feeds are encoded pretty efficiently, say 4 megabits per second for a standard HD stream, you aren't just stuck with one program per frequency.
Not at all. No. You can fit 12 distinct programs into that single RF carrier. You just aren't wasting any bandwidth.
Yeah.
The device takes those 12 IP streams, multiplexes them into one signal, and sends it right down the coaxials.
But for the person, sitting in the hotel room or the hospital bed with the remote control, it doesn't look like a jumble of data.
Not in the slightest.
Okay.
And that's where the VCT comes in, the virtual channel table. So you, as the operator, you get to map all those streams. You just tell the box, stream A is channel 2.1, stream B is channel 2.2, and so on. The viewer just flips channels like normal. All that complexity is completely hidden.
I also noticed the specs really emphasize that this is a pass-through device. That seems like a really important distinction for quality control.
Oh, it's crucial. This box isn't a transcoder. It's not taking the video file, decompressing it, and then recompressing it again, which would always degrade the picture quality.
So what goes in is what comes out.
Exactly. If you send it an MPEG-2 or an H.264 video stream, that is precisely what comes out the other end.
Yeah.
It's just changing the delivery vehicle, not the package inside.
Infrastructure varies so much depending on where you are in the world. Is this unit locked to, say, North American cable standards?
You would think so, but surprisingly, no. It's all software defined.
Mm.
If you deploy this in the US, Canada, or Mexico, you just set it to ATSC. But you could take this exact same physical box to Europe.
And just toggle a setting to DVB-C or DVB-T.
You got it. And ISDBT for Japan and South America. The RF standards for the entire globe are preloaded. It's a universal translator for coaxial systems.
It really just highlights that while we talk so much about everything going wireless and 5G, there is still just this massive, massive value in the copper wires already running through our walls.
It's a survival tool for coaxial systems. It proves you don't have to rip out all your infrastructure just because the source of your video went digital.
A smart, cost-effective bridge. But it does leave me with a final, lingering question for you to consider. We spend so much engineering effort building these bridges to keep legacy cable alive. At what point does the maintenance of the old coax outweigh the cost of just going fully wireless? Or is the reliability of a physical wire simply something we can't replace yet?
That really is the enduring debate of modern infrastructure, isn't it? Sometimes the old ways
Yeah.
they just work.